one is 0.014. Alpha is 0.12. The exponential term is 1, all right? The smoothing automatic, we leave it like that. The number of output data points, we can also get less, okay? The dose unit, it was in milligram, right? And then use observed time from input worksheet, let's do that. Use time, let's do from worksheet column, we can even, if we want to do the point by point with the dissolution, we can see if it let us to choose the dissolution. But then we have to specify. This one I'm not sure, right? We're going to figure out. And then the dose, we already put the dose. The dose was what? 200. And let's see what happened. Okay, so let's first of all look at this is the result, all right? This is how we're fitting the deconvolution, all right? So this is, so means we did a good job, all right? And this is the input. Eventually, this one we can put on a log. And you see on the log scale is a straight line, so means the input the first order. Again, I gave you perfect data. So eventually, like you did in the homework, once you get, even last week, all right, the homework you did with Excel, once you get the deconvolution data, then you're going to have, this is from last week, all right, the Excel. So in one case, if you have something like this, all right, on normal paper, so you have this was the amount at the absorption site and this is time. So because when you do on a semi-log paper, you get a straight line, so the slope will be Ka, all right? If instead, this one of the homework, all right, you use the Wagner-Nelson. When you plot on the normal paper, you get a straight line, then the slope, you don't have to take the log, the slope is directly K0. That is the zero order absorption like answer. So in one of the homework that unfortunately the name was telling you theoretically, because usually last year I was giving you just the data without a label, zero order and first order, okay, now that was a reminder for myself, but you saw it now. So that was the reason, okay, in one case the input was first order, in one case it was zero, right? Anyway, so this eventually is given to you, this one. So let's see what we're going to do now. I'm going to go fit the values. Okay, so let me go back. Because theoretically now we want to plot this one versus the versus the dissolution. So let me go back in the setup and see. This is use times from a worksheet column, but then it observe the time. Okay, mapping. Okay, no. There should be a way that
you can select the source from the above.
Okay, view source, all right.
The above the view source, select select source.
Here select source.
Okay, so worksheet.
Okay, all right. And now I want the time of the dissolution, all right. So this is it. So let's see. I get probably something that is identical to what I had before, all right, from this point of view. But what I have, the values, now are calculated at this time. So if I save it here, okay, then I'm gonna do here, no, this one, save it from the deconvolution. I can add a column. It would be the dissolution. And then I go back to this one. I can copy this column here. Okay, and now I can go and use send to plotting. And I want to plot the dissolution, gonna be my x, and the cumulative input will be my y, all right? And let's see, and it's a perfect straight line, all right? So this is something you will never see in the real world because these are all simulated data, but eventually this would be a level A Ivivc. Questions? And of course, I give you only one subject and one formulation. Theoretically, to have a level A, you're going to have 6 subjects and you're going to have 3 or 4 formulations. This would be the same that in the slides, we'll go back to the content. So it would be the same as this graph. The only thing that you have only one. Let's see. This one, you see? The only thing you can pretend that you have only the blue data, the blue dot. Theoretically, if you have to do another one, you're going to have the red and the purple, okay, all together. So this is what, and so you have. Now, let me see, because there is something else that I would like to do. If we go back to the worksheet, this one, okay? I'm gonna send to, I wanna see if we can do okay, you can do a Levy plot directly, let's see. Set up. The in vitro values from the convolution. This one. Okay, let's see. In vitro value from the in vitro, I put the in vitro, right? So it will be these two, all right? And the in vivo, okay, I have it in the same data set.
In vivo, you put the in vitro data.
Or did I?
Yeah.
In vitro.
That's correct. So now in vivo, the source is the worksheet, not the values from the convolution. So
Okay. So let's see. The source would be this one. Okay.
just remove this one. If you can remove this one.
You can select another source.
I don't know if in vivo I need to deconvolute.
No, we need, because on the y-axis is in vivo. On
Okay.
Levy plot is like in vivo versus in vitro.
Yes, but in vivo I don't understand if it's the in vivo PO data, you know, the plasma concentration, or the in vivo?
The plasma concentration.
Ah, the plasma.
Concentration.
All right. Oh, I see. Let me see. So we're gonna
Select the source.
select the source and the worksheet.
And times.
And
PO
times
is-
will be the PO. So you think you have to put this
Yeah.
one,
And now you can see.
and then I have to do match value.
So
And then
it's-
I'm gonna run it. It still is curved though, you see? The point of function. Anyway, this one I have to figure out. I don't. I don't remember to do, you know, the Levy plot. This is what we're gonna do, you know. The Ivivc is extremely sophisticated. So the other time I did the Levy plot was always part of the entire Ivivc. Anyway, that. Because one other thing you want to do in the homework is to calculate the absolute bioavailability, all right? Because I don't know if this is, this is something you might want to do because, again, I think it's not 100%. So this is something you want to discuss. You have the IV, you have the oral. You can also calculate the absolute bioavailability. It's not part of the question. All right? Absolute bioavailability fraction, all right? So, and that's it, okay? Do you follow me? I try to give you an example, very, very simple, of the reasoning that is behind the Ivivc, all right? Any questions so far? Do you like it? Did you ever heard about this? Did you ever, you should. I know it's not easy. Again, it's not, but this is something really, you know, something that there are jobs out there, right? There is a lot of requests for this type of stuff. Okay, so if you have no question, I leave you back. If you want to start to do your work, or you feel like we go home and then you can do. You can do by yourself. Again, from now on, this, let's say, the deadline to, it's not really true, okay? I would say the deadline to give me the homework will be the week before the exam, but I strongly recommend you don't wait until the last moment to show me your work, and maybe if you come with your homework next week, you have it with you, we can look it together, we can see, because again, the exam will be similar, all right, to these problems, all right? And I want the exam to be done with telling a story, not only put that number, okay? You should tell me your reasoning. That is what is it's relevant for me. I know the answer of the problem, all right? So that is not all that really interesting to me. I want to see you tell me the story, how you get to that answer, all right? It's not the answer per se, it's how you get to the answer, all right? Okay, so if there's no question, I close and give you back. I don't know, you want to work or you want to go?